Hello and welcome to the HIV Cure podcast. My name is Sakabo Marumo, and I am back again with another exciting episode where we are going to be breaking down HIV cure research as well as just science generally into simple language for you to understand and also have a voice when it comes to HIV advocacy and talk better and relate better with policymakers, leaders in the community, even, our presidents and ministers, for them to understand you better when you're advocating for the different things that are there, more especially HIV cure. Today, we are talking about long-term remission and a functional cure. And guess who's back? Adam is back again. Hi, Adam.
Hi, Sagabo. Thank you for having me on your podcast again.
Yes, thank you for coming back. The last episodes, people really enjoyed it. And I was like, you know what? We need to have Adam again. And also that people now, because some of these words are now, they keep repeating on different episodes.
Yes.
So like, okay, we need to understand better these words. And yes, so kindly just introduce yourself and let us in on what you do for those who are listening for the first time.
Well, yes. Hi, Sagabo. I'm Dr. Adam Ward. I'm the research program manager and statistician for a group called the Research Enterprise to Advance a Cure for HIV. We're one of 10 groups funded by the U.S. National Institutes of Health flagship program for HIV cure science. And I'm based with a group at Cornell Medicine in New York City. And I do broadly HIV cure research all the way from basic science in a laboratory, trying to understand better how and why HIV persists despite antiretroviral therapy, through to clinical trials testing new HIV cure strategies in humans. And so that's broadly the work I'm engaged in. I've been in the field for about 8 years now. And yes, look forward to delving into these topics in greater detail on this session on long-term remission or functional cure, as well as viral eradication.
Yes, thank you for that. And before we just go deeper into the episode, can you please explain the HIV language guide, because some of the words we're going to be using them interchangeably so that everyone is able to understand, and those who might have missed episode 2 can also know what we're talking about. We're not talking about the HIV language guide and also just person-centered language.
Yes, certainly. So I certainly encourage folks to look up the HIV language guide. So this, as you noted, focuses on person-centered language. So language that is respectful and centers the individual living with HIV and not the virus. This guide has been developed in multiple iterations. Really first comes out of principles established in the 1980s called the Denver Principles, but it's about respecting the individual and the person and centering them and not the virus. And so, I'd certainly encourage folks to look up the HIV language guide from 2024 and to familiarize themselves with current language and communication being used in the HIV field.
And just a disclaimer that we will be using some of the words interchangeably. Don't say that, you were just talking about person-centered language on the previous episodes, and now here you're going back to the old one. So we're just going to be using some of the old and the new terms interchangeably, just so that you're able to understand and also know and familiarize yourself with those words. So with that said, today we're talking long-term remission and a functional cure. So Adam, what's the difference between long-term remission and sterilizing cure?
Yes. So as I discussed briefly on episode 2, long-term remission, or what is sometimes called a functional cure, you may see that in the scientific literature. Community preferred term, which you'll see in the language guide, is called viral control alpha therapy. So this is the idea that a person living with HIV's immune system can control viral loads to low or even to undetectable levels off of antiretroviral therapy. And so the goal here is to give a therapeutic intervention that boosts or otherwise improves immune responses such that a person living with HIV could stop taking antiretroviral therapy, ART, and still maintain low viral loads. So that is viral control off of therapy, or what's sometimes called long-term remission or functional cure. The other concept, which you referred to, sterilizing cure, this is referred to also as classical or eradicating cure. That's the community preferred language. So the classical definition of cure, which means the elimination of all HIV infected cells in the body to prevent viral rebound if a person living with HIV discontinues their antiretroviral medicine. And so this is likely a very high bar to achieve, this eradicating or classical or sterilizing cure. And it's likely that a more realistic goal for HIV cure strategies is to induce long-term viral control off of therapy.
All right. Thank you for just explaining and clarifying that, and also just giving us the new terms that we're supposed to be using.
Yes.
And now then the question becomes that if someone, can someone who is in long-term remission still transmit HIV to others? Someone who's in long-term remission, can they transmit it to others?
Yes, so this will depend upon the person's viral load. So we know having an undetectable viral load means that a person living with HIV cannot transmit HIV to others. So currently, the vast majority of people living with HIV must take antiretroviral therapy in order to reach an undetectable viral load. But if long-term viral control off of therapy, or what you're calling here long-term remission, can be achieved through a therapeutic intervention, through a cure, which I should emphasize is still a very active area of research, and we currently don't have a way to induce long-term viral control in most people. But if we can, then it will be important to determine the person's viral load. So ongoing viral load monitoring will still be important. So we know that with U equals U, if someone is maintaining an undetectable viral load off of therapy, they are not at risk of transmitting HIV to others. And it is likely that a viral load, maybe perhaps there's immunological and other studies that need to be conducted, but a viral load perhaps less than 200 copies per milliliter of plasma, for instance, would confer a substantial reduction in the risk of transmission to others. But I think the question then becomes, what if a person's viral load spikes or transiently increases to, say, 1,000 copies or 10,000 copies? Then what is the reduction in risk of transmission to others? And also, is this spike transient? And then maybe stricter control of viral loads then resumes? Or is it more long-term? So I think the field must still determine what level of viral control can be achieved in most people living with HIV off of therapy, and then what are the implications for the long-term health of the person living with HIV and for the risk of transmission to others. But to sum it up, it will depend upon and ongoing viral load monitoring will be important.
And you talk about the fact that studies have been carried out over the years, and now there is what is called the Visconti cohort. So please explain to us what this cohort is, how did it come about, and why are they so important when it comes to HIV cure research?
Yes, certainly. So Visconti was a cohort of people living with HIV in France. It's called the Virological and Immunological Studies in Controllers After Treatment Interruption, or Visconti. And these individuals initiated antiretroviral therapy relatively early in the course of HIV. So within the first few months after acquiring HIV therapy in a closely monitored treatment interruption study. And these individuals exhibited control of viral loads to low or to undetectable levels for a median of 89 months after stopping therapy. So this was a very long time. Most people, if they stop taking their antiretroviral medication, the vast majority of people will experience what's called viral rebound, detectable viral loads within just a few weeks. But the individuals in this cohort exhibited control of viral loads for a median of 89 months. So here, these individuals did not receive any therapeutic intervention, no curative intervention other than standard antiretroviral therapy. And this study, and now also multiple other cohort studies, have shown that approximately 5 to 15% of people living with HIV, this depends on the area and other factors, can control HIV viral loads to low levels for a period of time, generally a few months to a couple of years after interrupting antiretroviral therapy. So these people acquired HIV, went on medication, but stopped ART and controlled viral loads for a period of time. So we call these individuals post-treatment controllers. And to review, these post-treatment controllers initially don't control HIV and experience high viral loads. They then begin antiretroviral therapy. But if they stop antiretroviral therapy, they're able to control HIV viremia generally for a period of a few months to a few years, but have to eventually go back on therapy. So a key factor in this Visconti cohort was that these individuals initiated therapy very early in the course of HIV. And indeed, more recent studies have shown that the frequency of post-treatment control is higher in HIV who are treated early, so within the first 3 months generally, versus people who are treated later in the course of HIV, which is called chronic HIV. And so this is important to the cure field because post-treatment controllers may serve as a model for HIV cure strategies, because essentially what we would like to do is induce post-treatment control in many more people living with HIV. So the field is still working to understand the immune mechanisms that govern post-treatment control so that hopefully we can target these mechanisms and achieve it in more people.
Okay, so it's all about starting treatment early, and when we're talking about that, there is like the test and treat strategy that says that any person who tests HIV positive to treatment, what role does early treatment play when it comes to helping people to achieve long-term remission or viral control of therapy?
Yeah, so as I mentioned in my response to the previous question, early treatment makes it more likely for someone to achieve a post-treatment control or viral control off of therapy. And this is due to multiple reasons. So first, early treatment, so starting therapy early in the course of HIV within the first couple of months, limits exposure to the virus. So the virus has less time to replicate and to diversify. So this results in both a smaller and less genetically diverse HIV reservoir. And I think this term HIV reservoir has been defined in multiple other podcasts in this series. So I would refer you to those podcasts describing what the HIV reservoir is. So by having a smaller and a less diverse reservoir, this makes it easier for the immune system to deal with the remaining virus. And then also, importantly, early treatment preserves immune functioning. So in chronic untreated HIV, particularly multiple years of untreated HIV, this results in what's called immune exhaustion. So our immune cells are constantly fighting. They're constantly trying to fight HIV, and eventually they can get exhausted. And so in chronic untreated HIV, there's both immune exhaustion and also poor immune functioning, as well as higher levels of inflammation and immune activation. And it may be difficult to fully reverse this immune exhaustion. There are therapies that are being tested and that have been tested in clinical trials to treat immune exhaustion in HIV, but it may be difficult to fully reverse even with therapy. So early treatment can play a big role in preserving immune functioning.
Okay, and then now we are going to dive into the immune system. So just explain to us then, how does the immune system contribute to keeping the HIV under control without any medication? Like, is there any special things that it's doing? Because earlier, on one of our previous episodes, we did touch a little bit about it, and also when you talked about BNABs.
Yes. So first, I'll stick with this topic of post-treatment control. Okay. So first, keeping with post-treatment control, evidence points to this being a complex phenomenon involving multiple aspects or multiple arms of the immune system. So it's also true that the specific immune responses involved in post-treatment control may differ between individuals, but it appears that for post-treatment control, what are called cytotoxic CD8 T cells, these are effector T cells which kill HIV-infected cells, that these can contribute to control. It's also true that HIV-specific CD4 T cells may contribute to control of HIV and post-treatment control. So remember that CD4 T cells are the primary targets of HIV infection, but these cells can also be immune effector cells, and they can be specific for and kill other HIV-infected cells. Cells called natural cells, which sort of bridge adaptive immunity and innate immunity, may play a role in post-treatment control. And it also seems that antibody responses can play a role in post-treatment control, particularly what are called autologous neutralizing antibodies. So these are antibodies against the virus that the person living with HIV develops, that are able to neutralize cell-free virus and prevent cell-free virus from infecting cells. And so it appears that, again, these multiple aspects of the immune system may all contribute to this phenomenon of post-treatment control. But another distinct form of HIV control off of therapy is called elite control. And so here we call elite controllers people who maintain undetectable viral loads without the need to go on antiretroviral therapy. So remember, for post-treatment controllers, these individuals needed to go on therapy to suppress viral loads initially. However, elite controllers are able to control HIV without needing to go on ART, generally for many years, although elite control can also be lost. And we've learned that elite control is generally mediated by a very potent cytotoxic CD8 T cell response. And so here, highly effective CD8 T cells that target other cells infected with HIV can readily kill HIV-infected cells. And these cells, these CD8 T cells, have qualities such as the ability to proliferate in response to HIV-infected cells. They're not exhausted. They have qualities that allow them to respond readily to HIV-infected cells. And so, those are aspects of the immune response that can help keep HIV under control without the need for medication.
And then these people that are able to be on remission or to have this viral control of therapy, do they have any sort of genetics that are making them to be able to be or to control the virus under remission? Like, what makes them so special?
Yeah, that's a great question. So for post-treatment control, there do not currently appear to be clear genetic factors leading to control. However, this is still actively being researched. But for elite control, there are strong genetic associations with control, specifically with what's called the human leukocyte antigen, or HLA-B locus. So HLA is a system of genes that encode for cell surface proteins called major histocompatibility complex molecules that are responsible for aspects of immune regulation. And in people living with HIV who are elite controllers, specific MHC class 1B proteins are strongly associated with control. So what is MHC class 1? So this is a protein that, in this case, on the surface of an HIV-infected cell, can present peptides or small fragments of the HIV virus to those cytotoxic CD8 T cells. And if those cytotoxic CD8 T cells recognize the parts of the virus being presented on the cell, on the surface of the infected cell, they will kill the HIV-infected cell. And so this clearly implicates a role for CD8 T cells in natural control of HIV. I should note that not every person who is classified as an elite controller may have these specific HLA genes, but specific HLA genes are strongly associated with elite control. Whereas in contrast, protective HLA types do not appear to be associated with what's called post-treatment control.
Okay, that was quite interesting. And I know that for those who are listening, for any person listening and they might be living with HIV, they're like, wait a minute, what if I could have that also? Like, I want that. So what makes it so challenges that scientists are facing in making sure that long-term remission or viral control of a therapy is possible for more people?
Yes, so that's an important question. I should mention also, in regards to the previous question about genetic factors, most of those studies have been conducted in the context of subtype B HIV, and so we still need more studies with diverse subtypes globally. And it's also possible that those specific HLA types are not present in all. But in terms of making viral control off of therapy possible for more people, well, this is exactly what the field wants and hopes to do and is actively working on. As I mentioned, we don't know exactly what immune mechanisms need to be targeted and boosted to achieve viral control off of therapy. We're still actively researching and testing many different strategies to induce long-term viral control. But what we have seen now, and what I talked about in the previous episode on season 2, viral control off of therapy from a few different HIV cure-related clinical trials around the world. And these trials all tested some type of immune-based intervention, and generally also combined that immune-based intervention, such as a BNAB, with some type of immunomodulatory drug. And so we're starting to see signals of efficacy now from a few trials and in a few people from those trials from around the world, but only a few people. So the vast majority of people from those trials had to go back on therapy. But we are intensely studying the individuals in those clinical trials who have controlled HIV off of therapy to better understand how they are controlling the virus so that we can hopefully replicate that in more people.
Okay, yes, I would really, really love that for us to see more people being able to control HIV off of therapy, because that's something that a lot of us want to. A lot of us have been on treatment for such a long time, and even just people who are newly diagnosed that just starting treatment and knowing that it's a lifetime commitment as of now, it's something that they will be like sort of like, yeah, it's quite excited to go into. So that's something that I'm looking forward to. And now when we're talking about these options, yes, in terms of progress that scientists are making, researchers, do you think that a functional cure or viral control of a therapy is enough, or would it be enough, or should we only focus on just completely sterilizing HIV, and why?
Yeah, so as I mentioned, I think it's a much more realistic goal for HIV cure strategies to induce long-term viral control off of therapy rather than viral eradication. So it is impossible really to demonstrate if complete eradication has been achieved because we can't sample for every potentially infected cell in the human body. Although we can measure surrogates, so we can measure what's called the size of the genetically intact, or the inducible viral reservoir in blood, as well as tissue biopsy samples. But we can't sample for every potentially infected cell in the human body. So it may be impossible to demonstrate if complete eradication has been achieved. I think that the field still is strategies are being pursued that aim for reduction in the size of the viral reservoir. And in fact, there's a concept in the field called reduce it control. The cure strategy is able to reduce the size of the viral reservoir. There are still HIV infected cells remaining, but there are fewer of those infected cells, and whatever is remaining is able to be controlled by the immune system better off of therapy. So I do think it's likely that HIV cure strategies that induce long-term viral control may also reduce the size of this reservoir, but may not result in complete elimination or eradication of the reservoir. And so the more realistic goal is likely long-term control off of therapy, where HIV-infected cells are still present in the body, but HIV viremia is controlled by the immune system without the need for antiretrovirals.
HIV can stay hidden in the body during remission. What then triggers it to come back up and then, just increase? And then also during this whole process, can someone in remission still pass the virus to other people?
Yeah, so this is a great question too. It's hard to know for every HIV-infected cell what may trigger it to start viral replication again. So we've talked about in the previous episode in season 2, and I believe in other episodes in this series, you've discussed what's called HIV latency. And so HIV may infect a cell, but then go transcriptionally silent. So no new virus is being produced, but that cell is still infected with HIV, and HIV has inserted its genome into the DNA of the cell that it has infected. And so the pool of all of those infected cells, even if they are not producing new virus, are called the HIV reservoir. And some of those cells can reactivate to produce new virus if they're dormant or silenced. We do know that CD4 T cells, which are the primary targets of HIV infection, are also important immune effector cells. And so they may be specific for other pathogens. So think influenza, the flu, CMV, cytomegalovirus, EBV, Epstein-Barr virus. CD4 T cells that are infected with HIV may be immune effectors that are specific for other virally infected cells. And so if the CD4 T cell that's infected with HIV, for instance, encounters what's called its cognate antigen, the protein, the part of the protein of these other viruses or of HIV itself that it recognizes, this CD4 T cell can become activated and can start producing HIV. And then there are other signaling pathways and other ways by which CD4 T cells can become activated and then may start producing new HIV virions. So it's also possible that infected cells can stochastically reactivate HIV production. And in fact, even under suppressive antiretroviral therapy, HIV-infected cells can still produce new viruses. So ART does not necessarily prevent a cell from producing new viruses, but ART prevents that virus from infecting new cells. And so some people living with HIV may have blips, and some people may experience what's called non-suppressible viremia. And the field has been studying this phenomenon now for a couple of years. And it appears that these persistent HIV-infected cells can still produce virus. They're still capable of producing virus, but ART, antiretroviral therapy, then protects new cells from becoming infected. And so to get to your question, though, about whether or not someone in remission can still pass HIV to others, this will, again, depend upon that person's viral load, like I discussed earlier. So it will depend upon the viral load in blood. And, you know, if someone's undetectable, then we know that equals untransmittable. But it will depend upon the viral load.
All right. And then now closing it off, when we're talking about communities, Adam, that how can communities and people living with HIV, those who are listening and just knowing others, how can they help when it comes to pushing for more HIV research being done on functional cures as well as long-term remission? Like, what is their role, and how can they contribute?
Yeah, so I think that given concerns over sustained commitments, especially by governments, in funding for the HIV response, we should all advocate for research into HIV cure. However, right now, people living with HIV must take antiretroviral therapy to maintain good health. So we must all push to ensure that all people living with HIV have access to art. I think that community participation in research is imperative for the eventual success. And I noted in my previous episode that I think an important starting point is for researchers to engage community members by providing accessible, understandable information about the current state of HIV cure science. And so I really appreciate that you're doing this podcast, which I think is very, very much helping to do. And as researchers, we have to build long-term relationships with communities and community stakeholders. So certainly, I think it's imperative for communities impacted by HIV to work hand in hand with researchers to advocate for both research funding into HIV cure strategies that focus on viral control off of therapy and eradication, but also to steer the direction of the research and to ensure that the strategies that are being developed will eventually be accepted and used by impacted communities. And so I think it's imperative for researchers and for community members to have that ongoing relationship.
All right. Thank you so much, Adam. And then just to close it off now, and this is just going to be a fun little question to say that if you could name a future functional cure, what cool name would you give it?
Yeah. I'm not sure that I am that creative. I think I just want to eventually see a cure or a set of different types of cures that provide options to people living with HIV that work, so they're efficacious, and that are scalable and accessible. I do think this functional viral control off of therapy will likely require a combination approach. So it may involve multiple different therapies that harness multiple arms of the immune response. I'm not sure I can put a name to one just yet, but I think we'll see then what future clinical trials show and what strategies are coming down the pipeline, and maybe you'll see some fun names come out of that.
Okay. So honestly, I did try. Adam is just not giving us the name, but so keep trying. We'll see how we're gonna treat him one of the episodes, and he's gonna give us a name.
I'll try.
Yes, please. Thank you so much for making time to join us again and explain to us some of these terms, and also just empower us to have that voice, that confident voice when we're speaking to other advocates, other policymakers, and just making sure that we, people living with HIV, understand the dynamics that are there towards finding a global HIV cure across the world.
Thank you for having me.
All right. Have a good day. And if you have any questions, you can comment. Adam, I'll send them to Adam for him to answer. And yes, if you want any clarifications also, I can always reach out for him to explain more some of the concepts. And also, if you have maybe a topic that you'd like us to talk about, please feel free to comment below or to just email me. We're going towards the end of the season, and season 2 is coming up. So do suggest some of the topics that you want us to talk about. Other than that, thank you so much for tuning in. I will catch you on the next and final episode. Goodbye.